first questions. Which evasion method is being used when TLS is observed between two endpoints? Okay. Next questions. How does an SSL certificate impart security between client and the server? Alright, topic on network security monitoring tools. Questions here. Which open source packet capture tools uses Linux and macOS? So I wanted to note some. Hello, you're welcome to 591 Lab. This is Cisco Certified CyberOps Associate 201 class. Okay, first of all, let me tell you about 591 Lab. So 591lab.com, pronounced as 591 Lab, is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission as 591 Lab is to provide our clients with exceptional exam preparation experience for certification in Cisco, Huawei, Harvard, Juniper, Palo Alto, and Fortinet exam track. Alright, looking into our agenda today, we're going to be looking at encryption and decryption, TLS and SSL, network security monitoring tools, network protocol analyzer, IP services, DNS attack, and DNS tunneling. Alright, let's quickly dive into our first questions. Which evasion method is being used when TLS is observed between two endpoints? Alright, so I'm going to be logging into a workstation to implement this TLS so that we can see what happens within two endpoints whenever you're using TLS to send the traffic between them. Alright, so I have two skills to implement that, which is OpenSSL. So I'll quickly look into our manual for this OpenSSL. Okay, we find out that OpenSSL is a command line tool. And then if you look down here into the description, we say OpenSSL is a cryptography tool keys and is implementing secure socket layer SSL and transport layer security network protocols and related cryptography standards. So we have all other related cryptography standards that we can use. It can be used for creations and management of private keys, public keys, cryptography operations, and all that. Alright, so okay, so quickly let's me point my directory here. Then I can see that I'm in the Anomalies under the home directory. We always use pwd to point your directory. So the directory, under the directories is where we have for that. Your directory just like document, your document desktops, and then download and all that. Okay, so I want to move to a directory where I have the file. Then we can use this OpenSSL to encrypt the file, so that we can have the idea of what happened to whenever we are using TLS and SSL on an application. So what is happening within the transport layer. Alright, so I will move into that directory by using what we call the CD, which is change directory. Then the directory is I'll go into my lab.support, okay, files. Okay, now so you can see that the directory have changed. Okay, then I can use ls. Ls is what we use to to list what we have, the content of what we have in the directories. Alright, so I will use ls now, so I can see that I have all these different files here. Okay, so let's quickly open this letter to grammar by using what we call cat. Okay, I'll use cat letter. Okay, grammar. Alright, so I have underscore there. Okay, so then I can view my file. You can see the letter that I have here. Alright, so since we're going to be using this OpenSSL to implement encryptions on this file, so we implement our TLS and SSL. So what I will do next is just for you to see the kind of cipher test that we can use, I'll just open SSL to implement this encryption. Okay, so we have these different cipher commands. Okay, yeah, so we're gonna be making use one of them. So how do we do that? So for we put OpenSSL, which is the command, the tools that we are using. Okay, then the next is to specify the cipher commands that I want to use. Let's say we are using AES -256, then CBC. Okay, so you have to make sure, that's why I have to show you this first. Make sure that you get your syntax right. Then we now specified our input files by just putting -in. Then our input file will be that's the letter underscore to grammar, right? And that file is in TXT. So make sure you get all that right. And then space our output now. So our output, which means in this case our output will now be the encrypted file. So we have to name it whatever I want to name it. So I can just name it as then we just put the command -out. Then we can say message. We can call it message to grammar, right? So but in this case now the extension is going to be ENC, I guess, because it's going to be the encrypted you get. So when we do that, once we do this, it's supposed to ask me for a password, so I can put in the password. All right, so make sure you remember the password so that you can use it for decryption. All right, so now so let's try to open that file. So by using the same card again, now I want to open the encrypted file, which is message, right? Okay, now you can see the file now. So now I'm gonna have one option. So this is a binary encoded form, right? So we are gonna change it to text encoded form by using an option -A. Okay, -A will change that encryption into a text-based encoding screen. Okay, so I'm just gonna repeat this same command that we have for this time. I'll just add -A before the in. You get -A. All right, so we'll see the difference between what we have before and what we're going to have now. So definitely still going to ask me for the same to input my password as well. So I'll just put the password. Right. Okay, now let's try to open it again so that you see the difference between what we have before and what we have now. Then cat message, let's go to grammar. Okay, .enc, right? All right, so now let's see now. So you can see now we now have base64 text-based encoding stream. So this is binary encoding stream, right? This is text encoding stream. All right, so now this actually this is kind of we implement this OpenSSL for you to see what happens whenever you're using TLS on an application. So within that transport layer, so your text are being encoded, in this form, whereby the check actors will not be able to see, what is going on those files. So the middleman will not be able to decode whatever you're having on those files. They won't be able to see them while you are transporting your files within the transport layer. Right, so let's just try to decode this same file back to the normal text file. So we just going to do the same thing. Put our OpenSSL. We're going to use the same cipher encryption algorithm, which is AES 256 CB. So but we're gonna use -A because of we use that option, the text base. We have used the text base, so we're gonna put the same option back. All right, then we now have -D so to decode to decrypt the file, and then our input files now. Okay, forget. Now we are going to specify our input file. So this time around, our input file will be our message to grammar.enc. Do you get? Right? Then, so we can now also specify another output file, which is going to be a test file. So we can name it whatever I want to name it. So I can just call it decrypt. Now, decrypted message to grammar.cst. All right, so you can see that it's asking me for password that we entered previously. Okay, so it has been decrypted. So let's open that now so that we see whether we now have a message back in the plain text. Very well. Okay, so there's a spelling there. Alright, so we have to be very careful about our syntax. So you can see now that we now have our text file in the plain text. Okay. Alright, so that's just for you. So we are going back to our question now. Going back to our question, so we can see that how we can use this, what this TLS is doing within the two endpoints. So which is basically is encrypting the two endpoints. So which invasion method is being used when TLS is observed. So when TLS is observed within two endpoints is encryption that we observe there. Alright, so let's move into our next questions. So our answer here is D. Okay, next questions. How does an SSL certificate impart security between client and the server? Already we have showed you, I've used a 2 keys, which is OpenSSL, for you to know what happened, whenever we are using SSL and TLS. So we don't want, without wasting too much time on these questions, we can see the option B by creating an encryption channel between the client and the server. So that's what exactly it's doing. So it's creating an encryption into endpoint. So that is our answer for this. Option B is our answer to this. All right, so moving to our next topic on network security monitoring tools. Questions here: which open source packet capture tools uses Linux and Mac OS? So I wanted to note some points here. Okay, we can see that first, this question is talking about open source packet capturing tools, and then it also emphasizes on used by what Linux and Mac OS operating systems. Alright, so so let's quickly talk about network security monitoring. Command tools that are used for network security monitoring tools can be network protocol analyzer such as White, Pack, and Deal, CP dumps, net flows, security information and event management systems, SIME, and it is common for security analysts to rely on your log files and simple network management protocols for network behavior discovery. So it is important that you make use of your log files to always do the troubleshooting as well as simple network management protocols. Alright, then now network protocols can we also call them packet sniffer, or we have here. Network protocol analyzer are not only used for security analysis alone, but also used for network. You can use it for troubleshooting, network troubleshooting softwares and protocol development and education. Just like we have the Wireshark here. You can see these aspects of our Wireshark. We use them for troubleshooting to analyze your network. Getting it, and then for Wireshark is we have Wireshark for Windows, we have it for Linux and Mac OS environments. So we have it. It's very useful tools for learning network protocol communication. So then a frame that is captured by Wireshark, they are saved in the pcap files that contains information regarding the frame, the interface, the packet length, the timestamps, and all the binary files sent across the network. Okay, so Wireshark can open files containing captured traffic from other software, such as TCP dumps utility. So we can capture a file from TCP dumps utility and use Wireshark to open that TCP dumps. Okay, so the examples here shows a TCP dumps. Okay, and then TCP dumps is a Linux pre-installed, is an open source. I get it. It's an open source utility in Linux and Mac OS. You get, and but not in Windows. So WinDumps is a Microsoft Windows variant of TCP dumps. Also, we don't have TCP dumps for Windows. Instead, we have WinDumps. And T-Shark is a Wireshark command line tool that is similar to TCP dumps. Okay, so we don't have TCP dumps for Windows. Okay. Okay, now so let's go back to our question. So which open source package capture tools use Linux and Mac OS? Okay, let's quickly log back to our Linux so that we can just find out one or two things now. Okay, now I can just see that so I'm still here. I can just do man TCP dump so that we just have idea of what TCP dumps, and we can see that it's already even installed. It's pre-installed on the Linux parameter. So these are Arch Linux. So you can see it's a dump traffic on a network. So we have these TCP dumps on Linux. Right. Coming back to our question here. So this is talking about which open source packages. So we this NetScott is an we also use this for to analyze network traffic, but it's not an open source. I get it. It's not an open source. Likewise, SolarWinds, they are not open source application tools, utility tools. Okay, and the NetSH is Windows utility tools for network configurations. Are you getting it? So is only TCP. TCP is as we can see that we have TCP. It's an open source which is pre-installed on the Linux environment, and then you can see the question emphasized uses Linux and Mac OS. Okay, so and then all these can be installed in either NetScott, SolarWinds. They are not open source application, and they have variants for either Linux or Mac OS or Windows. But for the TCP dumps is only for Linux and Mac OS. Alright, so that's why option D will be our answer. NetSH is for Windows. Alright, so D is our answer to these questions. Alright, moving into our next questions. A network engineer noticed in the net flows report that internal hosts are sending many DNS requests for an external DNS server. So a SOC analyst checked the endpoint and discovered that they are infected and became part of the botnet. Now endpoints are sending multiple DNS requests, but with spoofed IP addresses of valid external sources. So that's a key point we need to understand. So what kind of attack are infected endpoints involved in? So we want to find out which kind of attack are they involved in this kind of scenario, and so we have to take note of this now. Endpoints are sending multiple DNS requests, but with a spoofed IP addresses of a valid external source. All right, let's quickly talk about DNS and different attacks that we have here. So DNS is domain name service. domain name were created to convert the numeric IP addresses into a simple recognizable name. So we have a fully qualified domain name, which can always be like Cisco.com, all those Facebook.coms and all that is there for people to remember. But normally our network devices, they make use of IP addresses. So what we always have is we already have this DNS server that always do a name resolution. That's from this fully qualified domain name to an IP address that your network devices can now use to send your packet and your data from one point to another. So DNS protocol define an automated service that match your resources names with the required numeric network address. So it includes the format for queries, response, and data. Alright, so this DNS has different records. So we have A, an endpoint device, IP, NS, AA, as for the main exchange records. So your DNS server stores different types of resource records. So when a client make a query, that's like trying to resolve his name, because women, we cannot be cramming our IP addresses, so we are good with with all those names. But our network, they don't use those names, they use IP address. Okay, so whenever we put in those fully qualified domain name, system will first of all go and do the name resolution from the DNS before sending your traffic to your destination. So your client make a query, the server DNS process the first look at your own record to resolve the name, and if it's unable to resolve the name by using its stores record, it contact other server to resolve the name. So we always have a DNS server, and if our DNS server is not able to resolve that name, it look up to another DNS server. So, and after a match is found, it returns to the original requesting server, and then the server temporarily store the numbered address in the event that the same name is requested again. So you have a temporary cache. We call it a cache, whereby it saves those IP address of that fully qualified name. So in case that you're trying to go to that same site, so instead of it doing those requests again, it will quickly just do the resolve for you on your local DNS server. Alright, so that's what happened with DNS. And then so we have this hierarchical structure of the DNS. So we have the top level, from the top level to the to the first and second level. So just like our top levels are .com, .org, .ou, .uk, you get it. Then under that we can have a name like Cisco.com. Then you can see here now we now have what's it called, Cisco.com www, which is for the web server, FTP45 server, than the mail.cisco, which is for the mail server. Alright, so that's for the DNS. If I want to maybe find out about maybe I just know the fully qualified domain, I want to know the IP address, we have these tools that we call the NS lookup. So I can always type NS lookup, then once I can just put the fully qualified domain name. So you can see here now, you just give me the server that is hosting that particular site, and then the address that is attached to it, the names and the address and in IPv4, IPv6 from the record that we have. We said that DNS have different record A, I get in it. So it will pull. So it's just a tool that is a safety tools that we can use to do to troubleshoot name resolution. Is used just to verify the IP address that is attached to that DNS. Right, so that is NS lookup. Okay, now so let's talk about the attack. So this DNS, our DNS, because most times local DNS will not be able to do a lot of not be able to resolve some domain. The organization normally do is to look up to a public DNS so that to have a robust resolve DNS. Are you getting it? So you can look up to DNS in Google DNS like AA and all that. So look up to an open DNS, so your DNS may be vulnerable to an attack, and so the client queries outside its administrative domain. You can look up to query outside your administrative domain. So DNS open resolver are vulnerable to multiple malicious activities, and then so this attack can be DNS hijacking, whereby the threat actor will enable a malicious third party to take over the DNS settings and then reroute the user to a fraudulent website. So that can happen. So we refer that one as DNS hijacking. So we can also have DNS amplifications and reflections attack, whereby the threat actor send DNS message to the open resolver using the IP address of the target host. That means he's going to be using the IP address of that target host to send a query to an open resolver. So the threat actor has already sniffed into your DNS and then using your own valid IP address to do name resolution to the public address. Alright, then we also have the DNS flooding attack. So this is a type of distributed denial of service attack in which the attacker targets one or more DNS server in an attempt to disrupt that DNS services. So they are trying to deny the organization from using their DNS services, thereby they have make attempt to disrupt that DNS service. Alright, so now we also have DNS domain shadowing attack, thereby the attacker is able to gather your credentials and able to log into your DNS and then create subdomains and all that, create different domain to their own malicious server, so that anytime people are trying to go to one side or the other, instead of going to the right side, it can just be pointing to their own domain. So they can just create some subdomain into your DNS into your own DNS server. All right. So now coming back to our questions, let's look. So we look into this carefully. Like here now, it says endpoint are sending multiple DNS. Are you getting now? Multiple DNS requests, but with a spoofed IP address of a valid external source. So meaning that an external source, which is the attacker, is now using a IP address of the valid host in that particular organization to send a DNS request. And what do we call that? So that's not a DNS. So we're going to be talking about DNS tunneling. That's not DNS tunneling. That's not DNS hijacking, because DNS hijacking is that you're able to hijack your DNS, slip into your DNS, and then started to redirect you to another to a fraudulent site of that. So, but if you look at our option C, which is DNS amplification, so if you come back here, you can see that threat actors send DNS message to open resolver using the IP address of a target host. So in this case, when an attacker sniffs into your network using your own IP address to send a request to DNS, so that is DNS amplification, and that's exactly what happened in the case of our question here. So option C, is our answer to this question. So that's the kind of attack that are infected by that endpoint. Okay, now let's move to our next questions. A large load of data is being transferred to external destination via UDP 53 port. Which obfuscation techniques is used? All right, so let's talk about port numbers. Okay, so we have port numbers, well-known port numbers. So we have well-known port numbers, and these are different web port numbers. You can see that the question is emphasizing on the via UDP 53 ports. So you can see here that 53 port is UDP, is a domain name service. So anytime we are seeing port 53, so we should know that it's talking about DNS services. It's the port that is used for DNS services. All right, then the question looking at here is you said which kind of obfuscation techniques is being used. So you can see now a load of data is being transferred, and we know that DNS is to do name resolution, not to send out data. Do you get? It's not for sending out data. Now let's talk about DNS tunneling. So DNS tunneling is talking about when a threat actor who use DNS tunneling place non-DNS traffic, I guess, within a DNS traffic. So this method often circumvents security solutions. Whenever a traffic that is not a DNS traffic is being sent out of a DNS port, are you getting it? It refers to DNS tunneling, and that is exactly what happened here. You can see here that we have a load of data is being transferred to an external DNS via UDP port 53. And we know that port 53 is talking about DNS. You get? So transferring of data is not a query, it's not a DNS query. You get? So and that's why we this option A saying that connection to CNC, which is command and control. So that's not a connection to command and control, and this is not an unusual behavior for DNS. And so we refer this kind of scenario to be a DNS tunneling, and that is option C. So a DNS tunneling is whenever a traffic that is not a DNS traffic passing through the port. So we refer to it as DNS tunneling. So option C is our answer to this question. All right, so I want to thank you for attending today's class at 591 Lab. We hope you found these materials informative and helpful. Remember, practice is critical to mastering any new skills. So review this course content and keep practicing with 591 Lab helps and support. If you have any questions and concern, please don't hesitate to contact us. We appreciate your participation, and we look forward to seeing you in our future classes. Have a great day.